My name is Kyle Norman. I'm the additive manufacturing application expert here at MLC CAD Systems, and I'd like to thank everybody for joining us today. We're here to talk about the latest and very exciting introduction from Markforged, Blacksmith. Blacksmith is an automated quality control system for our flagship X7 3D printing platform. But before we dive into the software, I'd actually like to take a step back and let's take a look at what is driving Markforged to continue to bring us Industry 4.0 leading innovation to the market. Most people working in manufacturing have heard the term Industry 4.0. It's all the buzzword, right? So why should any of us be interested in it? Well, Industry 4.0 is the fourth industrial revolution of the manufacturing industry. We've already seen three major industrial revolutions in the manufacturing industry. Let's talk about those real quick, just to kind of set the scene of where we are today and how did we actually get here. So the first industrial revolution, it was when mechanization and steam power changed the whole concept of manufacturing. We went from hand tools and everything was very, very manual, and we began to introduce steam powered machines and mechanisms into the manufacturing areas. And then the second revolution, this is when we began to see the innovation of mass production, assembly lines. Electrical energy took place and enabled a huge step into production facilities, and a huge step in efficiencies, right? So when we saw electricity come in, just think about it. Think about manufacturing before electricity. I can't even imagine. So then the third revolution, this brought us automation, brought us computers, robots, brought all this to production. We saw production grow by leaps and bounds. It's been said for quite a few years now how the Internet of Things, the IoT, devices, sensors, digitalization, and big data can change the whole manufacturing industry in the next, 5 to 10 to 15 years. Well, it's no longer a question of whether it's going to happen or whether it's going to change the manufacturing landscape. The real question is, how fast is this evolution phase, and how fast will we see the implementation of all of these phases in the Industry 4.0? So Industry 4.0 really started to take shape in the 2010s. As computers became more powerful and the internet became more interconnected than ever before. Particularly important is the introduction of the smartphone. It allowed for the development of applications which could link devices, and we began to see the widespread use of Bluetooth and wireless technology. These days, the term Industry 4.0 is commonly used as a buzzword. We hear it all the time, everywhere. And we hear it for smart manufacturing processes and how the Internet of Things has become so interconnected that it can be used to simplify the production process. Overall, the main idea of this Industry 4.0 is to create a well-rounded and holistic ecosystem for manufacturing processes, technology, and applications. This idea of smart manufacturing will revolutionize how products are developed and lead to more automation and less routine manual labor. With the Industry 4.0 at the forefront of all manufacturers' processes and development of processes, Markforged entered the industry with a vision that no other 3D printer manufacturer had, and that was, let's bring as many of the Industry 4.0 core principles into our product line. To date, no other 3D printer manufacturer has incorporated as many of these core principles into their product line as Markforged has. With the introduction of Blacksmith, this is the next step towards adding AI to the additive manufacturing industry as a whole. Now, are we here today to discuss the introduction of AI into the Markforged platform? No, but the platform has been introduced and the stage has been set for the addition of AI into the platform. So what is it? It's called Blacksmith. Let's check it out. Blacksmith for the X7. So Blacksmith is an additive manufacturing platform that connects part design, production, and inspection, and sets the platform for the ability in the future to begin learning through AI. Today, Blacksmith inspects parts while they print and compares it to the design files. This automated in-process quality control solution reduces time to market and gives you, the manufacturers, the confidence in the parts coming off of the print bed. Everybody here today, what is your validation strategy? Do you have a validation strategy for additive for your traditional manufacturing? You know, many companies handle part validation in a myriad of ways, but let's simplify the scope into 2 conventional strategies. So the first being businesses that have no dedicated quality control resource. In the absence of dedicated part validation tools and processes, manufacturers must hope the part fits and functions properly when it arrives at the customer. As we all know, hope is not a strategy. This has gotten me before. And this risky approach often costs more in customer loyalty, logistics, and chargebacks than it would have cost to implement a conventional validation process in the first place. For this reason, most manufacturers opt to employ a validation process of some form or fashion. The tricky part about this is validation in its conventional forms is in fact a completely unique process, requiring additional steps after the part is produced. While some parts require a simple check with a manual gauge, opportunity, have you thought about printing those gauges you're using today in your quality control process? If not, call me. Others require resource-intensive CMM, laser inspection steps that tie up valuable operator time and add time that delays the manufacturing feedback loop. And this all just makes it arduous to detect and remediate defects. More damning, sometimes validation resources, even simple gauges, are not always at the same plant the part is produced, leaving manufacturers with a difficult decision to add schedule delay and logistics cost, or hit and hope for manufacturers with multiple locations and desperate plants, where we often find there is a lack of continuity of processes with respect to validation depending on the site the product was manufactured in. Meaning the same customer may have very different experiences with 2 different products coming from the same manufacturer. This is bad. So, which of these camps would you say your business is aligned with? Who owns the validation process in your facility? Is it outsourced? How has validation impacted your job here? So which of these camps would you say your business is aligned with? Think about that. Markforged is changing this paradigm with point of fabrication inspection, with a built-in, touch-free tool chain for delivering high-confidence QC reports. The Markforged printer equipped with the Blacksmith ensures the customer gets a right part every time with no additional cost, lead time, or skilled labor interjected into the process. So let's talk about the process. How does this work? So first we have a calibration step, and this is in order to guarantee the scan accuracy of the X7. Customers will need to use the OEM certified reference bed to complete this automated inspection calibration process. We've created a series of automated calibration procedures that are designed to calibrate the device to ensure printers are in their peak condition for Blacksmith. After calibration, you're actually ready to print a part at this stage. It will be scanned using the existing onboard laser on the X7. You will need to go into Eiger and turn on the Blacksmith toggle before slicing. When your part is being sliced, Blacksmith will then intelligently generate a laser inspection toolpath to ensure good coverage of your scan points throughout your entire part. Once a part is configured and a build is locked in, a user simply presses the print button and the printing and scanning process will be completed automatically with minimal impact to time. One interesting thing to note is that because we are scanning during the fabrication process, we're able to scan hard to access and internal geometries that would otherwise be impossible to view in a single step with traditional inspection techniques. So as you scan, a three-dimensional point cloud is created. Each point has a unique set of X, Y, and Z coordinates which corresponds to a measurement taken on your part. Blacksmith collects measurement data during the print and assembles a point cloud for you to review in Eiger. This point cloud automatically is generated and overlaid your input STL for comparison purposes. So verification. You can view your results in Eiger and select your part's critical tolerances. This top image shows the scan point deviation between the part design and the print. You're able to manipulate the part in 3D space so that you can see every side of it. The bottom image is what happens when you select a specific acceptable tolerance. If you need a part to be within 100 microns, for example, of the intended design, you can select that on the bar and all points above that will turn red so that you can evaluate if the error is acceptable for your particular application. Users can also view a part's historical scan data right on this page, making traceability easy. In the future, you will be able to create a very detailed, customizable print report that calls out specific features in your model. Ultimately, the most exciting thing about Blacksmith is that Blacksmith very soon will begin to learn at the speed of the global fleet. And what does this mean? Each printer is equipped with Blacksmith will securely send data to the cloud, helping the entire fleet get smarter. With each print, we will get closer to the right part every time. So ultimately, you're going to be verifying your parts and then confirming conformity of that part as you produce that part.